Legacy students, Marsh here. So today we're going to talk about rational zero theorem. You're going to want your notes today. You're going to want a calculator for some simple math when we do our synthetic division, pen or a pencil, and then you're definitely going to want some patience today. Patience is the key. So what happens if we need to solve a polynomial but it isn't factorable? What are we going to do? How are we going to solve those? So today is to find a way to solve a polynomial that cannot be factored. So today factoring is going to be needed at the end of the problem, but not definitely at the beginning. So you're going to need to find a hint. Basically, we're going to have to long divide or synthetically divide these problems first, and then they'll probably become a factored problem. Now, to find the hint, you're going to become a very educated guesser because you're not going to want to pick every number under the sun and see if it works. So you're going to use the rational zero theorem, which states that every zero or solution has the form of P over Q. P are the factors of the constant, or the number at the end, the guy with the no x, and Q are the factors of the lead coefficient, so end over beginning, so bottom to top. Now, some flashbacks that we need to remember. Rational zeros, that means rational means that they're going to be in a fraction form. So you're looking for numbers that are fractions, or they can be normal numbers, okay, like 2 or something like that. No imaginary should happen today, and you should not have irrational, aka square roots and stuff. So remembering those vocab numbers that we need to remember. So let's find the real zeros of this problem. First thing we're going to do is we're going to look at the factors of the end and of the beginning and compile a list of our possible rational zeros. So I'm going to go my P over my Q. So P's are the factors of the end. So all the numbers that multiply to give me 8. 1, 2, 4, and 8. Right? That all those multiply to give me 8. Now the thing is, -1 and a -8 will also give me 8. So all of these guys also have pluses and minuses to go with. Don't forget about that. Then we're going to look at all the factors of the beginning. So that would be 2. So plus or minus 1, plus or minus 2. So all the numbers that multiply to give me 2. So think, guys, if you would have a P of like 16, it would take forever to write all of those out. But nevertheless, this is how we can find our hints. Now what you're going to do is divide all of your P's by your Q's. So I'm going to go 1 over 1, that's 1. 2 over 1, that's 2. 4 over 1, that's 4. And 8 over 1, that's 8. Now let's divide these all by 2. So 1 over 2, that's a half. 2 over 2. 4 over 2. Pluses and minuses. And 8 over 2. Now, simplification is key. These guys simplify further, right? 2 over 2, well, that's just 1. And you already have that rational zero possibility. So you don't have to carry about him. 4 over 2, well, that's just 2, right? So don't worry about him. He's already taken care of. 8 over 2, that's 4. So we don't have to worry about that. So our list of possible zeros is plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. And then don't forget about plus or minus 1/2. Now, we have generated our rational zero list, possibles. Now we're going to use this list to find actual zeros. Here is where that patience part of this video is going to come in. You don't know which one works. You don't know which one is going to be a factor or a solution, aka we're looking for a remainder of 0 after we synthetically or long divide. So we're just going to have to test some numbers. I feel like 1. 1 would be a really nice number. So let's try synthetically dividing by a possible solution of 1. So then I'm going to set up my synthetic, starting with an x cubed, because that's the biggest number we're dividing by, right? So I got 2, negative 5, negative 14, and 8. So let's drop 2. 2 times 1 gives me 2. Negative 5 plus 2, that's negative 3. Negative 3 times 1, that's negative 3. That's negative 17. Negative 17 and negative 9. Frowny face. Did not get a 0. So 1 is not a possible 0, is not a 0 for us. Let's try negative 1. Basically, we're looking to see if we can win the lottery and get a number here. So let's distribute the 2, drop that down. 2 times negative 1 is negative 2. It's negative 7, 7. 14 minus 7. 7. Negative 7, actually. This would be 7. Dang nabbit. Frowny face. It's 15 there. So negative 1 didn't work. Let's try 2. Okay, distribute the 2. 2 times 2 is 4. It's negative 1. Negative 2. Negative 16. That's definitely not going to get where we need. Let's try negative 2 this time. Drop the 2. Negative 4. Negative 9. Oop, I'm feeling good about this. 18. 4. Negative 8. Smiley face. We got a 0. So I know right now that negative 2 is in fact a solution to our problem. So now what I'm going to be looking for is I want to divide 2x squared minus 9x plus 4. That's the new problem we're working on. So now I need to factor that. So I'm going to see if I can factor in that case. 2 times 4, that's 8. That'd be negative 1 and negative 8, right? So let's expand that middle term there. Oop, forgot to expand. I was so excited that I found a 0 that I forgot to expand. So that would be negative 1x, negative 8x, and a positive 4. These guys group, let's take an x out. And then these guys group, take a negative 4 out, can't take an 8 out. There we go, I have 2x minus 1 over here. So then I would have x minus 4 and 2x minus 1. So my other two solutions, so your solutions to your answers, or your answer, and I know that I need to have 3 of them because of this 3 right here. So you have one answer of x equals negative 2. That came from your division. You also have an answer of 4, and then we also have one more answer of 1/2, which came from the 2x minus 1. Let's try the next example. So I got 2x cubed minus 7x squared plus 9. So let's list our p's over our q's. So my p over my q. P is 9, q is 2, end over beginning. So plus or minus 1, plus or minus 3, plus or minus 9. 2 is plus or minus 1, plus or minus 2. So then that looks like my list of zeros would be plus or minus 1, plus or minus 3, plus or minus 9. That's me taking all these numbers divided by 1. Now we're going to divide them all by 2 as well. So plus or minus 1/2, plus or minus 3/2, and plus or minus 9/2. Alright. Whew, gotta feel lucky. Let's try, let's probably positive 1. Let's see if I can get a positive 1 to come. So let's start doing our long division, our synthetic division here. So I'm gonna put a positive 1 out there. So it looks like x cubed's the start. And no x. Oh, we're missing an x squared term. So close. We gotta put an x there. So we got 2. Negative 7, 0, and 9. So let's drop the 2. 2 times 1 is 2. That's negative 5. Negative 5, negative 5, negative 5. 4. Frowny face. Okay, let's try a -1 this time. 2, -7, 0, and 9. 2, it's a -2. This is a -9. That's a +9. Ooh. Yay! 0 remainder. So I know that -1, I'm going to put off to my side here, my solutions, felt pretty lucky. We have second try. X equals -1 is definitely one of those answers. It completely, fully divides in. So then I know that 2x squared minus 9x plus 9 is now the problem we're working on. So we need to see if this is factorable now. So 2 times 9, so 18. Two numbers that give us 18, but add together to give us -9. -6 and -3. That would get me -9, wouldn't it? So -6, -3. So I'm going to expand my middle term here. There we go. Group these guys, group those guys. So factor out a 2x. I'll be left with x minus 3. Factor out a -3. I'll get x minus 3 as well. So my two factors, after I factored, was 2x minus 3 and x minus 3. So my answers, or my solutions, because I know there's 3 of them based on my highest exponent there, I get 3 from here and then 3/2, which, if you notice, guys, 3 and 3/2, they were in my possible 0 list as well. That should always happen. All rational zeros that you have in your answers over here should be present in your list that you generated. Now, avoiding some errors. Be sure to list all positive and negative factors. Notice, guys, negatives definitely sometimes do come to be the best friend in the magic solution. Not every possible 0 you generate by your rational zero list is an actual 0. Not all of them are, in fact, answers. Those are your guesses or your hints, so you can narrow your guesses down. Patience is definitely the key. You definitely need to make sure you know how to synthetically divide, because otherwise you definitely can get yourself into a rut. So be careful with that. Tomorrow we'll do practice on this. Going to get a little bit more frustrated, but until then, see you later, Sabers.